Can you tell if this linked list has a cycle in it? Well, obviously you can look at it visually and see that this node -4 loops back around to 2, and that would be a cycle. But how can we do it with code? What we could do is iterate over the linked list, and at each node, add it to a list of nodes that we've seen. And for the current node, if it exists in the list that we've seen before, then there must be a cycle. But this isn't an optimal solution because we have to use O of n memory to store all the lists that we've seen before. Also, for each node, we have to check the entire seen list to see if it exists, and that adds to the runtime. The method we'll use is called fast and slow pointer, also known as the tortoise and the hare algorithm. We'll create a fast pointer that moves forward 2 nodes at a time, and a slow pointer that only moves forward 1 node at a time. Now, if these pointers reach the end of the list, we know there's no cycle, because a list with a cycle in it has no end. But if these pointers eventually meet up at the same node at the same time, then we know there's a cycle. So for the code, we'll initialize the 2 pointers, and we'll keep them moving as long as they haven't reached the end of the list. If at any point they're equal to each other, we return